Section 9.3 Part B. So these are the ones that are going to take a little bit more work involved because they don't look quadratic by any means. The first ones look quadratic. You see a square there, so we just set u equal what's inside parentheses. The ones below sort of looked quadratic, but they had too high of a power x to the fourth. But we could just see we did a substitution or just factor it using an x squared and an x squared. But on this next one, these do not look quadratic in form. So we're going to try what we wrote on that first page where it says, let u equal the middle variable. And we're going to see if we can make it be quadratic. So this definitely doesn't look quadratic, but we do see we have three terms. And when we have three terms, maybe we could make it quadratic. So we'll start off by saying let u equal the square root of x. We're going to let middle variable, not the middle term, just the middle variable piece. So the square root of x. Now we're hoping that if we square both sides, we're going to get the first term, which is x. So if I square u and I square the right side, the square root of x, what happens? I get u squared equaling the square and the square root cancel, and I get x. Now will that always happen? Yes, if it's quadratic in form. So we're going to let x now become u squared minus 6, the square root of x was u, plus 8 equals 0. And then like I said before, most of these will be factorable, but you could use quadratic formula if you'd like. This would factor into u minus 2 and u minus 4. So u would equal 2 or u would equal 4. But go back to what we said u was. Remember, u was the square root of x. So now I'm going to plug in. Now I'm going to plug in for what u was. So u was the square root of x, so the square root of x is going to equal 2, or the square root of x is going to equal 4. Then how do we finish this? We're going to square both sides to get rid of the square root. So we get x equaling 4. We're going to square both sides to get rid of the square root, and x is going to equal 16. Now, be careful, I'm not taking the square root, I'm squaring, so I'm not going to do plus or minus. Now here's where you got to be very careful, and I would make a huge note about this problem. You must check when you have square roots. Remember, because square roots, when we change something into a different form, we might get answers that work for a quadratic that don't actually work for a square root. So let's check x equaling 4. So we're going to put a 4 here, minus 6 square root of 4 plus 8 is supposed to equal 0. And let's make sure. So the square root of 4 is 2, and 2 times 6 is 12. So if I go through that, 4 minus 12 is negative 8, and negative 8 plus 8 is 0. Now we're going to check 16. So when I plug in a 16, I get 16 minus 6 square root of 16 plus 8 equals 0. So 16, and then minus, that's the square root of 16 is 4. 4 times 6 is 24, plus 8 is supposed to equal 0, and that checks out as well. So both answers do work. Sometimes both will work, sometimes both won't work. Sometimes one will, one won't. So make sure you're always checking your answers. Alright, so let's look at number 6. We have t minus 3 square root of t minus 10 equals 0. We're going to start off the same exact way. We're going to say let u equal the middle variable piece, which is the square root of t. Then we're going to square the left and square the right to see if we get the first variable. So we're going to take this equation and square both sides. So we get u squared equaling, what happens is the square and the square root, they cancel, and you're just left with t. So I know that t can now become u squared. So u squared minus 3u minus 10 equals 0. It is factorable into u minus 5 and u plus 2. And so u is going to equal 5, or u is going to equal negative 2. Now don't forget what you did. You have to go back and plug in for the original variable. So what was u? U was the square root of t. So the square root of t equals 5, or the square root of t should equal negative 2. So if we square this side, we're going to get t equaling 25. If we square this side, we're going to get t equaling 4. Now let's check our answers. When I plug in a 25 into the original, so let's check t equaling 25. So we get 25 minus 3 times the square root of 25 minus 10 is supposed to be 0. Well, 25 is 5, and 5 times 3 is 15, so we get minus 15 minus 10. Does it equal 0? Yes. Now let's check t equaling 4. If you plug in a 4, you get 4 minus 3 square root of 4 minus 10 is supposed to equal 0. Well, the square root of 4 is 2, and 2 times 3 is 6, so I get 4 minus 6 minus 10. That does not equal 0. So t equaling 4 gets crossed out. That's considered extraneous. Now, why did I get an extraneous answer? Because if you look back from the square root equal to negative 2. There's no way to take the square root if you don't have the plus or minus and get a negative. So if you kind of understand that a little bit better, you could have known that's not going to work. If not, just make sure you check your answers. Alright, now look at 7. Oh, now we got fractional exponents. Definitely does not look like they're quadratic. However, let's start off the same way. We have a trinomial. Let's see if we can make it be quadratic by letting u equal the middle variable. So let u equal x to the 1/4. Now what do we have to do? Just like on every other thing, we've squared the left and squared the right to see if we get the first variable. When I square the left, I get u squared. Now what is 1/4 x to the 1/4 squared? Well, we multiply powers, and this is 2 over 1, so we get 2 over 4, and 2 over 4 is a half. And that's what my first variable was. So u squared is now going to become x to the 1/2. So just like on all the other ones, if this is truly quadratic in form, you're going to be able to square this one and get to that one. So what's it going to look like now? We're going to have u squared minus 4u plus 3 equals 0. It's factorable into u minus 3, start over, u minus 3 and u minus 1 equals 0. So u would equal 3 or u would equal 1. What do we say u was though? U was x to the 1/4. Resubstitute for what u was. So u was x to the 1/4. So we'll come up here and we'll say x to the 1/4 equals 3, or x to the 1/4 would equal 1. So how do we get rid of raising something to a 1/4 power? Well, that means you raise it to the 4th power, right? So that's going to be x equaling 3 times 3 is 9, times 3 is 27, times 3 is 81. So we get x equaling 81. And then if we raise this to the 4th power and this to the 4th power, 1 times 1 times 1 times 1 is just 1. Now, do we have to check those? Not really. I mean, we should, because this is actually a square root and this is a 4th root. So when we put those numbers back in, hopefully they check out. How would I check them? I'd probably take my calculator, not a graphing one, but a scientific one, and make sure they actually check. So I'm going to let you check. You need to check answers and decide if they both work, if one works and one doesn't, or if everything's okay. All right, number 3. I'm sorry, number 8. I don't know why I said 3. Number 8, we have 3 parentheses plus 5 parentheses plus 2 equals 0. So right off the bat, you see parentheses. We're going to let u equal what's inside parentheses. So plugging in for u, since u is that, we're going to get u squared plus 5u plus 2 equals 0. At this point, guess what? Not factorable. So it's not factorable, we're going to have to use a quadratic formula. So u equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 2 all over 2 times 1. So u is going to equal negative 5 plus or minus the square root of 5 squared is 25, and that's going to give me an 8 over 2 plus or minus 25 minus 8 is going to be 17 over 2. Now what was u? U was x minus 3 over 3 equals negative 5 halves plus or minus 17 over 2. This is a challenging one. But again, I think we can still do it. So, easiest way to do it is to go ahead and multiply everything by 3, so I can get rid of my fraction. So I get x minus 3 equaling, remember we love multiplying fractions because we just multiply straight across. So 3 times negative 5 is negative 15 over 2. And then we have 17 times 3, which is 51 over 2. And then, I'm sorry, I left off my square root. That's not right. I was wondering what was going on there. 3 squared is 17. So we have 3 square root of 17 over 2. My bad. I don't know why I left off the square root. So we ended up with 25 minus 18 is 17. We get the square root of 17 over 2. When we multiply by 3 times everything, we get negative 15 over 2 and 3 square root of 17 over 2. The only thing is we still need to add the 3, and that's going to go to the first part. So we need to find a common denominator, which is a 2. And so we're going to multiply this by 2. We get 6. So we get negative 15 over 2 plus 6 over 2, and then plus or minus 3 square root of 17 over 2. So negative 15 plus 6 is going to give me a negative 9. So my final answer is x equaling negative 9 over 2 plus or minus 3 square root of 17 over 2. So much more challenging when they're not factorable, but you can still do them. Just find a common denominator and add the real parts and leave the radical real part unchanged. Alright, so on number 9, I'm going to start you off and then I'll let you finish it. On number 9, we should start off by saying let u equal x to the 1/3. If we square the left and square the right, you should see that u squared equals x to the 2/3, because all we got to do is multiply powers. And so that's going to turn into 3u squared minus 4u minus 4 equaling 0. This one is actually factorable, so if you want to factor it, you could. And once you do so, you're going to get answers of u equaling negative 2/3 or u equaling 2. Now remember, go back and say what you were saying u was from the beginning, which is x to the 1/3. And then how do you get rid of taking something to the 1/3 power? You're going to cube both sides. So you should end up with x equaling negative 8 over 27 and 8 as your answers. They should both work because this is a cubed root, which means it is a index of a 3, and index of a 3 is okay. Index of a 2 or 4 are the ones we have to check.